All right, ladies and gentlemen, here we go, section 7.3. We are getting after special angles. So this will be a bit of a refresh from grade 10, except we're now going to relate it to the Cartesian plane that we were talking about. So the first ones I want us to look at are called the quadrantal angles. Now that's just a fancy, weird math word for the ones that occur at each quadrant axis. So you got when it's on the x, when it's on the positive y, when it's on the negative x, and when it's on the negative y. So consider your line as it rotates around the axis. So obviously if it's at point 1, 0, x is 1, what's the angle that's created is 0 degrees. When you're at point 0, 1 on the y-axis, you're at 90 degrees. When you're at point negative 1, 0, you've gone full 180 degrees. And then when you get down to 0, comma negative 1, you've done your 270. And then if you get back to 0 again, you've gone full 360. You'll notice this is a slight typo, but not the end of the world. Here it says less than or equal to 360, and everything else you see, it'll just say less than 360 because 360 is the same as 0. So we use 1 because it's just a unit measure. It follows the unit circle, and it just has our radius equal to 1. And I'm going to show you how that relates to our special angles here shortly. So, example 1. Evaluate each trig function. Tan of 0 degrees. So, just think about that line of 0 degrees. So, if we draw the grid, and then we draw the line in red, say, 0 degrees is right here, right? 1 comma 0. And tan, remember, opposite over adjacent, or y over x, right? So, well, what's y in this case? It's 0 over 1. So, tan of 0 degrees is 0. And if you don't believe me, plug it into your calculator. Now, for the second question, is cosine of 180 degrees. So, again, take any point, but there's no point picking anything other than the negative 1, 0. It just makes life way easier. So again, we have our grid, and now you have your line. It's on that full 180 degrees. It's lying on this axis here at negative 1 comma 0, and we're doing cosine. So cos theta is x over r. Now in this case, we know our r is 1, right? R is always positive, but the x value is negative 1. So it's negative 1 over 1, so cos of 180 is negative 1. And now for C, 270 degrees. So again, if we look at the grid, right, well, where's my line at 270? We're all the way here. So we're going to be at 0 comma negative 1. And we're asking for sine. So sine theta, or in this case, let me be clear, not tan theta, tan of 0 degrees, cos of 180 degrees, sine of 270 degrees is equal to, sine is y over r, so we have negative 1 over 1, so again, negative 1. And then for the last one, we're looking at tan of 90 degrees. So, get your grid, get your line, that's 0 comma 1, tan is, so tan 90 is equal to y over x, opposite over adjacent, but in this case we have tan of 90 is equal to 1 over 0, and that is not allowed, can't divide by 0, so tan of 90 degrees is undefined. And if you continue into Pre-Cal 12 and you start graphing these trigonomic functions, you see some pretty interesting stuff that goes on at that undefined value for tan. Great. Okay, so now let's look at our special angles. So I hope beyond hope that you've seen this in grade 10, but it is very possible that this was either skipped over, covered quickly, or you just completely forget. And I'm quite confident that it's probably one of those three. So I'm going to make sure that I go through this again for you. And there's two different versions of the triangle. You can have a 45, 45, 90 triangle, or you can have a 30, 60, 90 triangle. We're going to look at the 45, 45, 90 triangle first. Now, we get these special angles, and these are ratios of similar triangles. So these numbers come about because they're the most basic of what they can be. Just to demonstrate to you what I mean by that, I have a 1 and a 1 and a root 2. These numbers could be multiples of any of that as long as it's the same multiple. This could be a 3, and a 3 root 2. Or this could be a 2, a 2, a 2 root 2. Or this could be a root 2 and a root 2 and a 2, just multiplying every side by the same value. But we strip it down to the most basic, being 1s, because it's the easiest to work with. So when you have a 45, 45 degree triangle, what I want you to think about is, if those two angles are the same, you have an equilateral? Nope. Isosceles triangle, right? This side and this side are the same length because the angles created between the two are the same. So in this case, we just say 1 and 1. And then to get this hypotenuse, to get the C value, Pythagorean theorem. Right? So that's where these ratios for this triangle comes about. So what you need to think about with respect to this right angle triangle then is, okay, well, what sine? Well, if we look at, bear with me here for just a second. If we look at this angle, okay, we'll use this angle as our angle of reference. Sine is opposite over hypotenuse, so 1 over root 2. Cosine is adjacent over hypotenuse, but also 1 over root 2 because it's the same. And then tan is opposite over adjacent, so 1. Those numbers need to be sort of burned into your brain. You're going to use them enough that you might have to draw the triangle, but it'll just start to become natural. When you see sine of 45 degrees, you know it's 1 over root 2. And that's what we call an exact answer. You could plug that into your calculator, get a never-ending decimal number. That's not what I'm looking for. If it asks for an exact answer, that is the exact answer. So that's where the 45-45 triangle comes from. Now, what about this 30-60-90 triangle? This is the other one where you have special angles. And this comes about similar to this, the proportions and the similarity, but of an equilateral triangle where every side length and every angle is the same. So if you look at this triangle in entirety, this side, and this side are all the same. They're all of length 2. And each angle, 60 degrees, 60 degrees, and then this whole thing is 60. So if you cut this thing right in half, right, you get a 90-degree angle. You've created two triangles. And if you cut it right in half, this 60 stays 60, but this angle becomes 30. So now that triangle looks like that. And again, this is where we get our values from. This 2 we started with, and this 1 came about cutting that side length 2 in half. So then where does root 3 come from? Pythagorean theorem. 2 squared minus 1 squared is equal to my missing side. So that's 3, right? We'll just say b squared. 3 equals b squared, so b equals root 3. So that's where they come from. And then again, depending on which angle you want to use as your reference point, I'm going to erase this stuff. Here's where we can measure the special angles. So if we're going to use 60 degrees, sine is opposite over hypotenuse. So sine of 60 degrees, root 3 over 2. Right? Cosine of 60 degrees, adjacent over hypotenuse, 1 over 2. Tangent is opposite over adjacent, which is why you get root 3. If you're going to use 30 degrees as your reference angle, opposite over hypotenuse, so 1 over 2, and then adjacent over hypotenuse, so they swap, and then 10. Basically 10, it's the reciprocal of each one. So these ones swap, right? And this is the reciprocal of one another. I don't mind. In fact, I like it if you draw the triangle when you start working on these questions so you don't screw this up. This is something that is going to become more and more regular for you, and you're going to use them over and over and over, particularly when you get into grade 12, and in this stuff a lot with your reference angles. This is why we do the reference angles. So, here we go. Evaluate sine of 210, and this isn't just like, oh, throw 210 into your calculator. I want an exact answer. So, think about where 210 is located first. Okay? 210 degrees is here-ish. And that's 180, right? And then that angle there is going to be 30 degrees, right? So that whole thing's 210, and just that little bit's 30. So your reference angle for 210 is 30 degrees. Now you're looking for sine, right? And you can see here that we're in Q3. So when you're in Q3, sine is negative, right? And here you have a special triangle. You have 30 degrees. So if it's 30, one good way to think about it is the side length is smaller when the angle is smaller. And 30 degrees is smaller than 60 degrees. And the sides are either going to be 1 or root 3 because the hypotenuse is always 2. So if it's 30 degrees, across from the 30 is smaller than the root 3, right? And then that's 2. So there's your special angle triangle. So what's sine of 210 when you're in Q3? It's 1 over 2, except the 1 is negative. So sine of 210 degrees is negative a half. And do that without using a calculator, without having to plug anything in, we can get an exact answer. So we'll look at now for cosine of 315 degrees. So again, where's 315? Well, I'm all the way over here, right? 315. Well, what's my reference angle? 45 degrees. So I have 45 degree triangle, which right away you say, okay, 1, 1, root 2. But you're in Q4, so you have negative 1. And we're looking for cosine. But the good thing about cosine is adjacent over hypotenuse. So cos of 315 is still positive, so it's 1 over root 2. And then tan of 120. So where's 120? It's in this quadrant here. It could be 90 plus 30, 120, which means that this, my reference angle, has to be 60. And you're in Q2. So you have a positive. So if this is 60 degrees, this is going to be my root 3. This is going to be my 1. And this is my 2. Thing is what is this here? Negative. I'm dealing with tan, which is y over x. So I know since I'm in Q2, I have a negative x value. It's going to be negative root 3 over 1, which is just negative root 3. So you're now using reference angles tied along with your special angles. There is what some teachers call the physics unit circle versus the math unit circle, but right now I just want you to focus on this because you can see that technically this isn't a unit circle because your hypotenuse is 2, your radius is 2. But don't worry about it because right now this is about getting your special angles. Just so you can consider what would happen if I wanted to get a radius of 1. You would divide everything by 2. And you'll see that you get your special angle values. So the special angles take into consideration a simplified triangle going from a hypotenuse of 2 down to a hypotenuse of 1 through division. But like I said, they're similar, so just keep working with it the way you're looking at it here. Here's just a quick diagram of some special angles. Numbers will start to jump out at you. And now here, these are all reference angles, right? So what is sine of 30 degrees? Well, if it helps, draw it. That's 30 degrees. 1, root 3, 2. So sine of 30 degrees is 1 over 2. Sine of 150 degrees, while you're in Q2, sine is still positive, is still 1 over 2. Sine of 210, you're now down here. Well, the only thing that's changed is sine is now negative, so it's negative a half. And then same with sine of 330, negative a half. It's the same reference angle the whole way through. Only thing that changes is the positive and negative values of where that angle is located. And that's the whole point here. That's why we made such a fuss about reference angles, and now we're making such a fuss about special angles. If we look at example 6, 45 degrees. So here, here, and you know that it's going to be a 1, a negative 1, a negative 1, a 1, and a negative 1. And since we're doing cos, the hypotenuse is always root 2 for all these special angle triangles because it's 45 degrees. So cosine in Q1 and Q4 is positive. So you'll have the same answer. You'll have 1 over root 2. But then in Q2 and Q3, it's negative, so you'll have negative 1 over root 2. And that's the whole point. That's all we're trying to achieve here, is to demonstrate that shift. So obviously Q4 is the 315 degrees, Q1 is 45, Q2, Q3. And then the last example is with tangent. So we have 60 degrees. So that's 60, which means that that's going to be root 3, 1, and 2. And all that changes is what quadrant we're in, right? So when you're in Q1, 60 degrees, it's tan, so y over x, so root 3 over 1. When you're in Q2, you're at 120 degrees, and the y value is still positive, but the x value is negative, so it's negative root 3. When you're in Q3, and this is that all students take calculus, like where is each thing positive, right? You have a negative y value, negative root 3, and a negative 1. So Q3 is the 240 degrees. You have negative root 3 over negative 1, which is positive root 3. And then in Q4, you are at 300 degrees. And again, we are at a negative y, but a positive x, so negative root 3. So you'll see we jump from going positive to negative to positive to negative. Now, here underneath is a summary of all the special angle values, but you are going to lose your mind if you are constantly flipping back to this summary because you don't know how to work through them logically and considering drawing a little triangle. So get used to actually trying to write down that triangle, which value goes where, so you're used to using it over and over. So you're not always flipping back to a summary page. Okay? All right, so now can you work backwards? That's the next step. Okay, so the reverse process. Given an exact value for an angle, what is the angle in question? So look at this first example. Find all the angles, okay, so not just one, such that sine is root 3 over 2. So the first thing that should jump out is, okay, root 3 over 2 is positive, and sine is positive in Q1 and Q2. The next thing you should look at is, okay, I have root 3 over 2. So since you don't see a root 2, you know you have a 30, 60, 90 triangle. So draw it. And you want your opposite value to be root 3. And you know your radius is 2. So that is usually, oh, okay, that's a 60 degree triangle. So note you have your reference angle of 60 degrees. So since it's positive in Q1, you know that your answer is, okay, well, 60 degrees. And it's also positive in Q2, so what's the reference angle when that's 60? Or when the reference angle is 60, right? What's this? 120 degrees. So you get both your answers. Both of those, sine of 60 is root 3 over 2, and sine of 120 is root 3 over 2. So now we're tying in special angles, we're tying in reference angles, and we're tying in quadrants. And what is the value of the trigonomic function in the quadrant that you're in? So this next question we have cosine negative. So before I even do anything, be like, okay, negative. I know cosine is negative in Q2 and Q3. It's the first thing I'm going to identify. The next thing I'm going to notice is that I have a root 2 here, which means I have a 45-degree triangle. Because you have a 1 and a root 2, and root 2 is only presents itself in a 45-degree triangle. So basically then, reference angle 45, you're in Q2 and Q3. So it means you have a 45-degree angle here, and you have a 45-degree angle here. So you're trying to find the angles, the actual angle with those reference angles. So this one here, right, is 180 minus 45. So your Q2 answer is 135 degrees. And then the next one is 180 plus 45. So your Q3 answer is 225 degrees. Both of those, if you were to plug them into your calculator, would give you the result of negative 1 divided by root 2. Okay, you identify the quadrant first. It's the best place to start. So a couple more here. This time we're dealing with tan. You can see you have a root 3. So think about, okay, well, what does it mean when I have root 3 as my opposite? Well, if you draw this triangle and you had a root 3 here and you had a 1 here, if that's the angle you're dealing with tangent, right? Opposite over adjacent. That's your opposite. So obviously this is not a 60-degree triangle. That's the wrong drawing, right? You need to be like, okay, well that can't be right because my opposite has to be 1. And if my opposite is 1, and that's root 3, then you have a 30-degree triangle. So you get your reference angle, 30 degrees. You also notice that we're dealing with tangent, and it's negative. And where is tan negative? Tan's negative in Q2 and Q4. So you're now trying to find the reference angles with a reference angle of 30 degrees in Q2 and Q4. So Q2 reference angle of 30 gives you an angle of 150 degrees right there. And then Q4 is 360 minus 30, so 330 degrees. Now I might be going through this kind of quick, but it's because I've done it a bunch and it becomes intuitive. But you're going to have to work through this a lot. So watch these references again. Now you'll notice here for question 8 it was find all angles. For question 9 it was find all angles. For question 10 it was find the smallest one. So I've solved for both of these, but the only one I care about for my answer is the 150. All right, and now lastly, doing this without special angles. So we've already kind of looked at an example where we work backwards. So if you're given a ratio that's a decimal, work backwards from it. So find all such angles such that cosine of theta is 0.632. So first thing we want to do is we want to find what is that as an angle value. So you'll see here, calculate it using the inverse cosine button, and you get 50.8 degrees, which means 50.8 degrees is the reference angle. Now, the next thing to notice is that this is cos theta and it's positive, which means cos is positive in Q1 and cos is positive in Q4. So your reference angle in Q1 is the same as your angle, so 50.8 is an answer. And then also in Q4, but it's 360 minus 50.8, so we're going to get 309.2 degrees. So when you're dealing with a numerical value, obviously you can't use special angle triangles, but you still need to find the reference angle value. And you'll see another one here, for example, 12. Now in this case we have sine of negative. So right away I'm seeing sine negative. I know I'm going to be looking for Q3, Q4, but since I'm looking for the smallest positive one, forget Q4. Q3 is going to be my answer. So basically, find your angle value not of negative, but of positive value, because that's still going to be your reference angle. So in this case, it's 45.3 degrees. So we're in Q3, which is 180 plus 45.3. So the smallest positive angle is going to be 225.3 degrees. Play around on your calculator, practice with those, but really it comes down to understanding your reference angles, understanding the value of the trigonomic function in the given quadrant. You're tying everything together here. And then this last example is an example of literally drawing up a triangle to help you visualize the scenario. So you'll see in this question it says, find the exact area, which means I don't want repeated decimals. I want something with a root in it, or without a root if that's the answer that I'm going to be given. Now, I have a triangle with side length 11 and 9 and an angle of 60 degrees in between. So to draw that, I could say, okay, well, 9, 11, and I know that that's 60 degrees. I don't know that side, but that doesn't really matter because I need the area, right? And what's the area? Area of a triangle is 1/2 base times height. Now, if I'm going to use the 11 as my base, that means I need a height. And you can drop your perpendicular from the top of this triangle to create a height value. And at the same time, you've created a right angle triangle with 60 degrees. Now, sine of 60 degrees is equal to opposite over hypotenuse. So 9 times sine 60 equals h. So I'm going to get I have my base, it's 11, right? I'm going to get my h, but I don't want to calculate a decimal value here. I want an exact amount. And I know that sine 60 is equal to root 3 over 2. So 9 times root 3 over 2 gives me 9 root 3 over 2 for my height. So now I can calculate 1/2 times 11 times 9 root 3 over 2. If it helps, it's 11 over 1. And you're multiplying all of this together. So 1 times 11 times 9, 99 root 3 over 4. Can't simplify it because 4 is only divisible by 2 and 99 isn't. Centimeters squared. That is an exact solution. There's no decimals to it. You're not cutting off a non-repeating, non-terminating, infinite decimal expansion. You're good to go. So, first chunk of this is finding reference angles. Second chunk of this is practicing solving for special angles in various quadrants. So work through this. Try your best to get good at the special angles without having to flip back to that summary. Draw yourself the triangle. Get used to drawing it and writing it. It'll help get you that sort of muscle memory going in your brain. Okay, so that's 7-3. We have 4 sections to go and we are done.